All right, people. All right, it is working. All right, people in here and other people that are at home, what's up? We're rolling here. We're going to talk about solubility today, and I'm going to talk loud because my microphone's not working, but I'm getting the microphone. It'll be in here in about 5 minutes, and I'll hook it up, and we'll keep rolling. So, I'm going to talk to you about solubility today. And when we talk about solubility, we're talking about making solutions. I mentioned all these terms last week, and this is all very simple stuff. Some solutions you may make at home are like Kool-Aid or sweet tea. Anything like where you pour a powder into water and stir it up, that's a solution, okay? The biggest solution on earth is the saline solution called the ocean, right? That's saltwater minerals and things from the rocks are dissolved into the water. Okay, now when we talk about this, there's two terms, the solute and the solvent. The solute is what's being dissolved, and the solvent is what's doing the dissolving. So this would be the salt, and this would be the water. Now, there's a nickname for water I mentioned last week. Does anybody remember it from the video or anything? If you don't, I don't blame you. Water's called the universal solvent because it dissolves a bunch of stuff. But it is far from universal. If you remember last month, I got some yellow powder, some sulfur, and tried to dissolve it in the water, and it just floated around on the water and stayed dry. Okay? So water doesn't really dissolve everything, but it dissolves most things that we work with. Different solvents dissolve different types of things. And I can show you a really cool example right here on the board. Well, here's a dry erase marker, right? And then it's made to, I can just wipe it off, and it's a special type of ink, right? But if I use this permanent marker on the board, and I can't wipe that off, right? Because it's permanent. And if I've got some water on it, got some water right here. If I got some water on it, put a little water on this. That doesn't do it, okay? So water is obviously not the universal solvent. But you got some? Cool, thank you. All right, people at home, I got some batteries, so hopefully be in business here. Super fancy. And now we're hooking up. Let's see if this works. Check. All right, that's working now. Good, we're in business. So, water's obviously not the universal solvent. I just tried to wipe this off with water and it wouldn't come off. But I can get some of this terrible smelling hand stuff, put it on here, and it'll take it right off. So different types of solutions dissolve different things, okay? And that's going to lead us to something we talk about a little bit later, maybe not even today. But I'm going to go ahead and write this term down. And a term that you should know is like dissolves like. So when we talk like solvents dissolve like solutes, okay? And basically where this comes from is polar solutes will dissolve in polar solvents, and nonpolar solutes will dissolve in nonpolar solvents. An example of this is salt is polar, right? It's an ionic compound. It's polar. It's got two different ends, a sodium and a chloride, and it will dissolve in water. When we talk about polar, check out water is water, isn't that a bent polar molecule, right? So water dissolves things that are polar. Now, if you have things on your hand like grease and oil are nonpolar nonpolar solutes and nonpolar solvents. So if you're working in the garage, you have a different hand soap if you're trying to clean gas and oil off of your hands. And a lot of people just use acetone or paint thinner, or I use gasoline or WD-40. Those things are all non-polar, and water is polar, so like dissolves like. Well, let's go back and take a look at this. The two solutes that we use in class and in cooking and in general society are sugar and salt. Those are both solutes. Those are the two solutes, the two utes. This is a movie scene you wouldn't understand. Your parents might if they were watching this. All right. So what does that lead us to? We can graph the ability of a solute to dissolve in a solvent, and look at what's changing down here. If you look on the x-axis, this is temperature. So what does this tell you about most powders as they dissolve in water? What does it tell you? As the temperature goes up, you can't hear them. Yeah, you can't hear them at home, people, but they all were screaming. The solubility goes up. That's right. As the temperature goes up, the ability of the powder to dissolve in the water goes up. Now, if you had some water and you kept heating it and heating it and heating it and heating it and putting more and more sugar in it, well, pretty soon you can have syrup. Does that make sense? Now, if you look right here, here's salt. Salt doesn't change much with temperature. Salt doesn't change much with temperature, but most of these other powders do, okay? This one actually goes down, which is a little bit unusual for a solid, okay? So let's talk about this. Here's solubility of salt and sugar. Salt is down here. Salt hardly changes, okay? And then sugar changes greatly with temperature. Okay. So then you could be asked a question. You could be asked a very simple question, like on the worksheet you're going to have. You're going to have a worksheet like this, okay? And it's going to talk about a graph. Well, let's take a look at this graph. I could ask you simple questions about the graph. I could say, what is the solubility of sugar at 40 degrees Celsius? And you go, okay, here is 40 degrees Celsius, and here is the line for sugar. The solubility of sugar at 40 degrees Celsius is about 240, and you see this as grams of solute dissolved in 100 milliliters of water. So 240 grams per 100 milliliters. That's the solubility of sugar at 40 degrees Celsius water. 40 degrees Celsius is a little over 100 degrees Fahrenheit. Does that make sense to everybody? So that's very soluble. Now, if you had a solution and you had exactly this much in it, that would be called a saturated solution. That would be called a saturated solution. Okay? If something is saturated, that means it has the maximum amount of solute in it. Okay? In that particular volume of water. It means you can't put any more. What would happen if you tried to put more in? It wouldn't dissolve. And you would just see the powder like going around in circles. Does that make sense to everyone? All right. You may have seen this at a restaurant when you ordered sweet tea and they didn't have any sweet tea and they just gave you sugar at the table and then you dumped it into cold water and you stirred it and stirred it and stirred it and then the sugar just went around and around and around in circles, right? So cold water doesn't dissolve sugar very well, does it? Right? But hot water does. Okay. if you're on this line, you're a saturated solution, okay? Now, what if we were down here? What if you only had 150 grams in the water? What if you were down here? You wouldn't be saturated anymore. You could put more in, couldn't you? You'd be considered unsaturated. What does unsaturated mean? It means what? It means you could put some more in it, right? You could make it a little bit sweeter, right? So like when your grandma's on a diet and you go over and you get some sweet tea at her house and you're like, this is terrible. She's like, well, I didn't put as much sugar in it. Unsaturated, okay? And then lastly, do y'all think that if we tried, we could ever get, if this is our line of saturation, do you think we could ever get this much sugar in it? Think we could ever be above the line? What do you think? I got some no's and some yeses out there. Could we ever be above the line? Yes. And when you are above the line, you are called super saturated. And that's basically every soda you've ever had in your life. Super saturated. Okay. Now, if you look, the saturation of these solutes depends heavily on the temperature. So how do you think we could get above the line? If we can manipulate the temperature of the water. Here's what we would do. We would take this water and we would heat it up to 62 degrees Celsius, and then we would saturate it. Does that make sense? And then we would turn around and cool the water off. And then when we cool the water off, the sugar doesn't come back out. It stays dissolved. Does that make sense? Now, when and where and how do people do this at their home all the time? If they're making sweet tea or lemonade or Kool-Aid. How do you do that? That's right. You use hot water. Have you ever made Kool-Aid or sweet tea before? And the directions say, use hot water. And then what else? Use the hot water and you dump it all in and then you stir. And then after you make it, then you cool it off. That's called super saturating a solution. Now, that's how we make sodas. And there are a few other tricks to making sodas so sweet called corn syrup. But that's how we make sodas. So if we look at these graphs now, and we understand about saturated, unsaturated, and supersaturated, then we could ask you some really simple questions about how we may get to different spots on this graph, okay? So I'm going to do one with you, and then I'm going to let you roll on the worksheet, okay? Here's the question. 80 grams of sodium nitrate are dissolved at 20 degrees Celsius. So 80 grams of sodium nitrate are dissolved in 100 grams of water at 20 degrees Celsius. Describe this solution. And you say, okay, 80 grams, here's my grams, at 20 degrees Celsius, I'm right here. Okay? And then I would say, what solute were we talking about? We were talking about sodium nitrate. Okay. Oh, here's sodium nitrate right here. Oh, we're below the line. Evan, give me, is this saturated, supersaturated, or unsaturated? It's unsaturated. And not only that, Maisie, how many more, and I know you can't see it from here, but I could ask you, how many more grams could we put in? And you'd be like, well, yeah, well, you can see it from there. All right, excellent. We could put in about 5 more grams. We could go from 80 up to 85. Does that make sense? So that's how these questions are going to be asked. Below the line, unsaturated. On the line, saturated. Above the line, supersaturated. How do you make something super saturated? That's right. You heat up the water first, put in your powder, and then cool it off. Does that make sense? All right, I'm going to give you a little worksheet on that. People at home, peace out. Now I see I can't. I just said that looking all cool, and then now I can't hit stop correctly. Stop and